Everyone hear me okay? Okay, so welcome to session 503, Making Great Touch Apps in XAML. My name is Ulnar Ismail, and I am the XAML Input PM. I also own the accessibility, the printing, and the data binding stories in XAML. So to give you a bit of background on who I am, I started out at Microsoft as a developer using the Microsoft web platform. I then transitioned to Silverlight as a PM. And now, of course, I'm the PM for XAML for Metro-style apps. So let me say first, thank you for showing up. I know last night was the attendee party, and 9 o'clock is extremely early. I'm touched that you showed up. Pun intended. No? Nothing? All right. Thank you. Thank you. I try my best. It's early. OK. So also, I'll mention that if you have any questions on anything you see here, I'll be available after, just on the floor here and outside. And also, I'll be at the booths basically after the session for most of the day. OK, so in the keynote on Tuesday, you saw that Windows 8 introduced new touch capabilities that really define and shape the user experience. In this session, I want to talk about how you can get those same touch capabilities in your XAML app. So first, I'm going to talk about our controls and how they enable some of those touch capabilities. I'll talk about how you can customize panning and zooming. And finally, I'll talk about advanced touch scenarios or interactions and how you can leverage our touch API. My goal in this session is to leave you with examples of how you can easily use the touch API to build advanced touch scenarios and how you can quickly build great touch apps out of the box using the controls we provide you. So with that, I'm going to jump into a demo of a great touch app. Now, you guys have probably seen memories quite a bit if you've been to some of the other XAML sessions. But I'm going to walk you through this app with a different perspective. I'm going to talk about the touch behavior, the touch language, and also talk about the controls that we're using in this app and how they support those touch behaviors as well. So as you can see, and as you know, playing with your device, Windows 8 is just more direct because you get to use your finger as a tool. So I can directly interact with the content. And that just makes the whole experience more engaging. Now, you see here, I'm sliding my finger from right to left, left to right, and the content is following. And that's actually the first behavior in the touch language, slide. So I slide my finger to pan the content. Now, if I want to go into one of these albums, all I do is tap. So I simply press and release, and that's a tap. OK, so great. Again, I can slide my finger across the content here. And you'll see that I've got inertia. I've even got a bit of a bounce when I hit the end of the album. And if I go to the start of the album and I kind of drag it out a little bit, like this, you kind of see that personality. We're using the scroll viewer here. And the important takeaway is that if you actually play on your own devices and you go to the start menu and you try and pan through the apps, you get the exact same behavior. What you're seeing in XAML is what you're seeing in the actual shell. So as I mentioned, this is a scroll viewer. And I'll talk about the scroll viewer quite a bit in one of the next sections coming up. OK, so what if I want to edit one of these photos? So let's take this photo here. So all I have to do is I swipe from the top or bottom, and that invokes the app bar. Now, you see, when I swipe from the bottom up, this app bar invokes, and when I tap, it dismisses. This touch interaction is all built in to the app bar. You get it for free. You just use that control, and all this is built in for free. So let's go ahead and edit one of these photos. I'll just tap on Edit. Oops. There we go. And I'll select one of these photos. So I'm going to crop this media. So another gesture that you guys are probably familiar with by now is pinch. So I can pinch to zoom in, and I can pinch to zoom out. And so that's another behavior in the touch language. And this actually uses the touch API, which I'll get to in the advanced scenarios. So let's cancel out of that. OK, the next thing I want to show here is how to reorder. So you see here, again, I can pan all the images in this photo album, and they're aligned in a grid. So the control we're using here is the grid view control. And since the grid view pans horizontally, to select or to reorder, I swipe vertically. So I'm going to swipe my finger to select it, and you see now it's detached, and I can drag it wherever I want. So because it pans horizontally, I swipe vertically to select and move. OK, so that's the grid view. That's, again, all that is built into the grid view control. So let's get out of here. The next thing I want to show you is our text controls. So I tap into the text box, and immediately the touch keyboard shows up. And if I actually start typing here, you'll see that I get text prediction as well. And again, all this great behavior is built into the text box. All you do is you drag it onto your canvas, and you're ready to party. Oops. OK, so let's close that out. And hopefully this will dismiss. Or not. All right, let's get out of that. Let me go back for a second. OK. OK, so I've showed you a bunch of controls there, a bunch of the touch language. And you know that Windows 8 is touch first. But that doesn't mean we've sacrificed the mouse or keyboard experiences. In fact, they still work great. So I'm going to use my mouse here. I think you guys can see that, right? And you'll see that I'm able to still click on the album to invoke the primary action, which is to actually go in the album. I can use the mouse to scroll all the content using the scroll bar. I can invoke the app bar by right-clicking. And I'll edit here. And I'll just show you how to reorder some of these pages using the mouse. Again, the grid view pans horizontally, so I just drag it vertically, and I can move that wherever I want. And so that's the same experiences with the mouse. OK, so let's go back to the deck. So you saw that a lot of the common touch scenarios are enabled out of the box through our controls. So in this next section, I just want to give you a quick overview of some of those controls that you saw and some you didn't, and talk about the touch language they support. OK, so controls that support the touch language. So first we have the grid view and the list view. Now the grid view you saw in memories when I was rearranging the pages allows you to pan horizontally. It supports swipe for selection and for reordering, and also tap to invoke. The list view is very similar to the grid view, except it just goes, you can pan that vertically. The flip view is a control you didn't see in memories, but you can see it in the inbox app Pickstream. And it's great for photo album applications. So the only difference here is that you can actually only pan one item at a time. So great for a photo slideshow. OK, another control you did see in memories was the scroll viewer. And as I mentioned, I'll talk about this in detail coming up. But it supports panning, which you saw, and also the first type of zoom in Windows 8. So Windows 8 supports two types of zooming. The first is optical zoom, and that's like a camera zoom, where you increase the magnification or the scale. The final control, and also the second type of zoom in a Windows 8, is the jump viewer, and it supports semantic zoom. So I'm sure you've seen this quite a bit. It's one of the value adds of Windows 8. If I have a large collection, I can pinch to zoom out and see a high-level representation of that data, the groups, and then I can tap or pinch to zoom in and see the actual group items. And from detecting the pinch to switching the views to running the animations, again, all that's built in out of the box using the jump viewer. OK, so you saw a lot of the common touch scenarios are enabled out of the box. But what if you want to customize some of those behaviors, like panning and zooming? So in Windows 8, direct interaction, where I use my finger to slide to pan content, or I pinch to zoom in and out, it has to be responsive for it to be a fast and fluid user experience. And across Windows, we've made significant investments to ensure that panning and zooming is buttery smooth. And to get that same fast and fluid experience in your apps, you'll want to use the scroll viewer. So I'm going to show you a couple demos using the scroll viewer. So I'll switch back to the dock here. OK, so this first demo is about snap points. So the demo is basically a scroll viewer, and I have some images. As a user, I can slide my finger up and down and just look through the images. But I can get into a state as a user where I can kind of get into a funky view, like this, where I can see part of one photo and part of the other photo. And that's not providing me much value. In fact, it causes me work, because as a user, I want to see the bottom picture. I have to drag it into view. But now I've kind of gone too far, and I can kind of see part of the other picture. So OK, I have to be precise. And that's a lot of work. Now, we as developers want to make our user experience effortless. And that's where snap points come into play. So if I toggle on snap points here, you'll see that the behavior changes. As I start to slide my finger up and down, it actually snaps to the next photo. And that's because I'm able, as a developer, to control the view now. So the photo always ends up in a desirable location. And after I go through a couple more demos, I'll actually show you the code to enable this. But also notice that if I go with inertia, I also snap. So it's always ending up in a good location. It's providing my user a value. OK, so the next example I want to show you, I want to go to see the Rails. OK, so in this demo, I have a scroll viewer with a magazine article in it. And again, as a user, I can pan this content up and down wherever I want to go. And you can see how fluid and fast and fluid it is. But, OK, I'm kind of standing still here, and I want to read this second paragraph. Barack Obama was born. And so I'm dragging it across. But I'm having to do work not to move my finger vertically. And that's great, because I'm standing up here, and I'm able to do that. But what if I'm on a plane and I hit turbulence? Can you imagine what that's going to look like? That's a bad user experience. And again, we want to make sure that our users are having a good user experience. So that's where Rails come in. So as I toggle Rails on, you'll notice that as I start panning horizontally, I snap to a horizontal rail. Now watch that circle. I'm going vertically, but it's not moving vertically at all. It's staying horizontal. And so I've snapped into a horizontal rail. The same thing applies if I pan vertically. Again, I've snapped into a vertical rail. I can't move horizontally. Now, does this mean that Rails disables two-directional panning? It doesn't. If I decide to pan diagonally, you'll see that I can still go wherever I want. I won't snap to a rail because I've gone on a diagonal. So Rails basically allow your users to snap to a certain horizontal or vertical rail, but they can get out of it by just panning on the diagonal. So those are Rails. And again, I'll show you the code to how to enable that experience coming up. Oops, I keep doing that. OK. So the final thing I want to show is how you can customize the zooming experience. In this demo, I have a scroll viewer with an image I grabbed off Facebook. So it's not a high-res image. And again, as a user, I can pinch to zoom out. But I've kind of gone too far here, and I have to do work to kind of bring it back. And I can pinch to zoom in. But all of a sudden, it's kind of getting pixelated. That's not it's not a high-res image. That's not a good user experience. So again, I have to do work to kind of bring it out. So as a developer, I can customize this experience. So first, I've set a min and max zoom factor. I'll only allow you to go 50% out and 4 times the magnification in. I've also decided to set some familiar zoom levels, like 100%, 200%, 400%. So notice, as I pinch to zoom out, I can't go any further. And as I pinch to zoom in, I actually snap to a nice zoom level. And again, I can't go more than 400%. And so that's it. That's the snapping in and snapping out. And so those are using snap points. And I'll show you the code for that as well. So actually, let's get to that code now. OK, so enabling snap points. Since I showed you a demo with vertical panning or vertical sliding, I'm setting 2 properties on the vertical axis. So vertical snap points type and vertical snap points alignment. Now, the type can be of 3 things: mandatory, optional, or none. Mandatory is what you just saw. The user has no choice but to hit that snap point. I, as a developer, control that view. Optional means that if the user is being really specific and really fine-grained control of what they're doing, we won't snap to that snap point. However, if they're going with inertia and they're kind of being a bit lazy, we will snap to it. So it really depends on how the user is interacting with the app. And of course, none means you just don't want any vertical snap points. Now, for the alignment, again, you have 3 values. You have near, you have center, and you have far. Since I showed you the vertical demo here, near corresponds to the top of the viewport, center is the center of the viewport, and far is the bottom of the viewport. You also have the horizontal snap points type and the horizontal snap points alignment. For horizontal alignment, near is the left of the viewport, center is the center, and far is the right of the viewport. So the other thing to notice here is that in the stack panel, my images are all the same height. And it's because I'm using something called regular snap points or uniform snap points, which means internally, we take a look at the first child of the container, which is the stack panel, and we look at the image and we see, OK, it's a height of 533 pixels. We then assume that since you're using uniform snap points, every other child is also the same height. So we apply a snap point every 533 pixels. OK, in this next example, in this next code snippet, we have Rails. So Rails are actually the default experience. And this slide is gratuitous, because you don't actually have to set these properties at all. But I'm just doing it for benefit here. So you have horizontal scroll mode and vertical scroll mode. If you're familiar with Silverlight, you've seen this before. We've added one new value, which is Rails. So in case you're not familiar, horizontal scroll mode and vertical, they can be enabled, disabled, or Rails. So enabled means you want panning in that direction. Disabled means you just don't want any panning. And Rails means you want panning, but you want that experience I showed you where you snap to the horizontal or the vertical rail. And finally, we have customizing zooming. So you could set the min and max zoom factor in XAML. I chose not to. I showed it on code here. But adding snap points has to be done in the code. It's basically a list of floats. And so I'm just adding some floats to that. So those common zoom levels, so 1, 4, and 8. OK, so you saw in the first demo that a lot of the common touch scenarios are enabled out of the box. You saw in the second set of demos that it's easy to customize those experiences. I mean, you only have a couple properties in all of these. Oops, let's go back. So I mean, 2 properties to get snap points, 2 properties to get, well, actually no properties here to get Rails as a default experience. And you can easily set min and max zoom factor in XAML. So again, just 2 properties, and zoom snap points is 1 property. Not a big deal. So that's great. But what if you want to build some advanced touch interactions? You want to leverage something called gestures or the low-level input events. How do you do that? So what's a gesture? Well, a gesture is a high-level interpretation of user input that corresponds to a user action. And I'm sure that's clear as mud. So let's walk through an actual example of what that means. So as a user, if I press my finger and release my finger, that input is being sent to a Windows gesture recognizer behind the scenes. That recognizer is running some mathematical algorithms to detect gestures. And then as a result, we raise an event in response. And those events could be tapped, holding, or right tap. So that's the user action. So we're trying to map the user input to a user action. Now, the great thing about having a Windows gesture recognizer is that every single Metro-style app, and even the shell, the start menu, uses this gesture recognizer. And that means you have consistency. All your users will know that a tap is a tap is a tap all across Metro-style apps, whether it was built in HTML5, whether it's in the actual start menu, or it's in your XAML app. They'll have confidence in their interactions because it's consistent. So the Windows gesture recognizer detects gestures for touch, mouse, and pen. And I'll get to that in a second. But really what it means is that you can code for touch and get the right behavior for mouse and pen. And that's what we encourage you to do. Code for touch and get mouse and pen for free. And we've done some things to enable that. So let's walk through these events one by one. Now, tapped is pretty straightforward. I tap my finger. I press my finger. I release my finger. And we raise a tapped event. Holding is a little bit complicated. It has a couple states. And it really depends on how and when the user moves their finger. So when I press my finger, and I'm there for, I dwell for a certain amount of time, we'll raise a holding event. And then depending on what I do next, I'll get another holding event with a specific state. And I have a code snippet coming up to really walk you through that. Right tapped is the universal right click, and the equivalent for pen. And that's where you get to leverage that code for touch, get mouse and pen for free. The best practice here for right tapped in a touch world is to show the context menu. And that's exactly what you want to do for mouse as well when someone right taps. So if you code for touch, you'll get the right behavior for mouse and pen. Now, all these gesture events are routed events. They go directly to the UI element that received the input. And because Windows 8 is touch first, all UI elements are automatically opted in for gestures. But we have a couple flags here: is tapped enabled, is holding enabled, and is right tapped enabled, to really let you configure what you want to do. OK, so this is the holding code snippet. And you see here that I've got some holding event args and a switch statement. So this event, again, is raised when the gesture recognizer detects input. So I press my finger on a UI element, I dwell there for a certain amount of time, and we raise this holding event to that UI element. And what will happen initially is that we'll get a holding event with the holding state equal to started. And depending on what I do next, one of two things could happen. So if I decide that I'm holding and I'm going to start a drag or a pan, then, or I decide to do a pinch to zoom in and out, well, I've just canceled the hold there. So instead, now you get a second holding event that will raise with the holding state equal to canceled. So you've canceled that hold. So I was holding, I decided to pan, and I canceled the hold. Alternatively, I could be holding for a little bit of time. I'll get the holding event with holding state equal to started, and then I'll release the hold. That's a hold complete. So I was holding, and then I released. And so you get two events there. You get the holding event with holding state started, and the holding event with holding state completed. Now, in the touch world, I mentioned right tap. So we know that right tap for mouse is equivalent to right click. But in the touch world, right tap is only raised after I get a holding event with holding state completed. That's the only time we'll raise that event. OK, so something similar to gestures, but a tiny bit different, are manipulations. So I'm going to show you a demo here of how you can scale, rotate, and translate some UI elements. OK, so in this demo, I have a canvas with a couple UI elements on it, some images. And I'm able to translate the content using my finger. I'm able to zoom in, or scale, I should say, scale the content. And you can see I can also rotate the content here. I've got inertia on the translation. You can see that right there. I'm able to manipulate multiple elements at the same time. And so I'm able to basically manipulate all these UI elements. So I'm scaling, I'm translating, and I'm rotating. And of course, since it's multi-touch, I can do multiple elements at the same time. And again, it's got the inertia. Oh, that just went off screen. OK, so how did I build that experience? So we have something called the Manipulation API. And if you're familiar with WPF, or you built Windows Phone 7 apps, this will look familiar to you. However, it is unique to XAML for Metro-style apps. So just out of just a poll in the audience, how many people have used manipulation events in Windows Phone 7 app development and WPF? OK, so a number of you. So I have a demo coming up next where I'll walk through how you actually manipulate an element. But I'll just walk through these events one by one. So manipulation starting is raised when an element opts in for manipulations, setting the manipulation mode, which is the property, and I'll show you that in the code snippet. And it's as soon as the element gets input. As soon as we detect input on an element, whether it's going to be a manipulation or not, we just don't know, but it's your last chance to configure for a manipulation. So basically, it's your final chance to configure that manipulation. Manipulation started occurs when we actually detect a manipulation is happening. So was it a scale? Was it a translate? Was it a rotate? As soon as we know something is happening, we raise that event. Manipulation delta is the same as in WPF and in Silverlight. We tell you what's changed. How are they scaling? How are they rotating? How much are they translating that in the x or the y axis? Completed is pretty obvious. It's once you release your finger, you've completed the manipulation. And that's your chance to do any cleanup work if you need to. And inertia starting is after you've released your finger, that element kind of flies across the screen a little bit. You saw that in the demo. That event is raised to basically tell you that, OK, we're going to start applying inertia to your element. Do you want us to? You can cancel out of it if you want. So let's take a look at some code. OK. So this is the XAML of the, well, it's actually, so the demo I'm showing you here is a bit of a scope demo. I'm only showing you how to rotate an element. But everything I talk about can be applied to scaling and translating as well. So in this demo that I will show you on the device a little bit later, I have a canvas and I have an image. And what I've done is I've set the manipulation mode to rotate, because that's all I care about in this demo is rotate. But you have a couple options. So you see here, I have all, which means rotate, translate, scale. None, which means I don't want anything. And by default, you're opted out of manipulations. So gestures, you're opted in by default. Manipulations, you have to enable. And by setting the manipulation mode, that's how you enable them. So again, you have rotate. I can rotate with inertia, scale, scale with inertia. So you have some options here. Let's put that back to rotate. OK, so since I only care about rotate, I've set rotate. So here's the code. Now, the first step is to be able to actually manipulate that UI element. I need to create a rotate transform. And I'm going to apply that rotate transform to the image and then update it to manipulate the photo. So again, this is pretty straightforward if you've seen WPF and Windows Phone 7, if you've done this before. But if you haven't, it can be kind of overwhelming. So I create a rotate transform. And I'm basically setting the angle to 0. Since there's no manipulations on it right now, it should look exactly how it shows up in the XAML. And I've set the center point, which is the middle of the image. The next step is to set that as the render transform. So I'm basically saying I want to apply this rotate transform I've created to the image. And if I had changed the angle, you'd actually see it rotate when we start up. But since the angle is 0, it's got no effect. Then I'm subscribing for the manipulation events. And that's the starting event and the delta event. So manipulation starting, again, is raised when we detect input on an element. You've set the manipulation mode. You've told us that you care about manipulations. As soon as there's any input, we raise this event. And manipulation delta is so I can respond to the changes. The user is modifying or is manipulating the element. I need to apply those manipulations to the element. OK, so last chance to configure the manipulation starting. Now, in this demo, I could actually get away with not hooking this event. But I want to show you single finger rotation. We enabled that as well. So that's what I'm doing here. I'm setting a center point and a radius on the pivot object. And I'm basically saying that, again, the center is the middle of the image, and the radius of the rotation is going to be 20 degrees. And I handle that event. OK, and here's the meat of the demo. I'm actually going to get the positional changes, and I'm going to apply them to the image. So I applied a rotate transform on that image. I grab it off the image again. I pull the manipulation delta structure. I do some math to convert it to an angle, to degrees, sorry. And then I apply that back on the element. So it's pretty straightforward. But let me show you the manipulation delta structure. So because I only care about rotate, when this structure comes back, it's only going to have the rotate value. It's basically a matrix transform. If I cared about scaling and translation, I'd find those values in there as well, and I could play with them. I could do the same thing. I could create a scale transform and a translation transform, apply those to the image, and then update those as well. And again, so then I just update that rotate transform on the image, and that's all there is to it. So let's switch to that demo real quickly, just so you can see it working. OK, so here's the image. And I'm using one finger to rotate the image. And I'm using two fingers to rotate the image. And that's all there is to it. You can try it. So I think because I've set the center point to the center of the image, it's going to still rotate around the image, around that center point. If I updated the center point to this contact, then I'd be able to do the scenario you're talking about. OK. Well, I'm more than happy to talk to you after the talk, and we can talk about that scenario. OK, so the only thing I haven't mentioned about manipulations is that, again, they are, I think you saw that they're routed UI elements, routed events to the UI element. And they're also being raised in response to that gesture, Windows gesture recognizer. Oh, another demo. So it's great. So we've got gestures and manipulations. These events are being raised by the Windows gesture recognizer. But what if I want to respond to the raw pointer events, the ups, the downs, the moves? How do I do that? And so the canonical example here is a painting application. But really, any high-fidelity application or a gaming application, you want to use the raw pointer events. So I'll show you this demo. OK, so I have an image here. And I can give this guy some glasses. OK, I'm not the best artist here. I can give this girl a mustache. And I can draw a sun up here. So this is using those low-level pointer events. So what's the API that empowered this experience? Let's grab a drink real quick. OK, so quick question. How many of you have actually started to play with XAML and use the touch API that we have there? Has anyone actually done that? One person? OK, so the first thing you'll notice is that we don't have mouse API. There are no mouse events on UI element anymore. And why is that? Well, we've introduced a new concept called the pointer. And before I show you the API, I want to talk about what a pointer is. So in Windows 8, we've unified the view of input across touch, mouse, and pen. So why? Well, the reason is that we allow you now to code against a generic form, a generic pointer. So you no longer have to have code in 3 places, one that handles touch, one that handles mouse, and pen. Now, it doesn't mean that you can't target your code for each device. You can get to the actual input type, whether it's a touch, or mouse, or a pen. But in general, again, we advise you to code for touch first and get mouse and pen for free. And that's exactly what this pointer API allows. Make sure you're thinking about touch first. And if you use a mouse, like I showed you in memories, it just works. So let's look at the class hierarchy here. So we have something called a pointer device. And that's actually the physical device, so the touch digitizer. And then we have something called a pointer. Well, a pointer is how you interact with that digitizer, so with the pointer device. So in the case of touch, it's my finger. Or maybe it's a mouse. And I can have multiple pointers on a device. So if I've got 5 fingers on that device, I've got 5 pointers, each one uniquely identified with an ID, so a contact ID. Now, each pointer generates pointer points. When I press my finger, I move my finger, I release my finger, that generates a stream of pointer points. And actually, the pointer point is a structure that has a ton of properties on it. I'll show you a few in the next code snippet. But you can get to the contact geometry, a bounding rect around it. You can get to the pressure. You can get to the location. You can get to a lot of cool stuff. And some of them are very easy to get to, and some where I have a property bag where you can just dive into that property bag for the more advanced properties and get to it as well. So if you've used the mouse API in Silverlight, WPF, you'll recognize that the pointer API is very similar. I mean, sure, there's a couple name changes here. We've changed it from present to past tense, so it's pressed instead of press, and it's not up anymore. It's not down. It's pressed. But if you know how to use the mouse API, you innately know how to use the pointer API, and it was designed for that reason. We wanted to make it comfortable and familiar for you, so you can code these great touch apps. So I'll quickly walk through these. Pressed is when I press my finger down. Release is when I release it. If I've pressed and I start moving my finger, I get pointer moves. Once I enter over the bounds of a UI element, I'll get the pointer entered event. When I leave my finger, when I exit the bounds of a UI element, I get pointer exited. Pointer canceled is something new, and I'll talk about it in the next slide. But it's raised when you abnormally lose a pointer. So if you rotate your device, you'll get a pointer canceled. If you disconnect an external digitizer, you'll get a pointer canceled. Capture lost is pretty self-explanatory, and pointer wheel is for the mouse wheel. So let's take a look at some code here that showed how I enable the painting with pointers. So pretty straightforward. I hooked 4 events: pointer pressed, pointer released, and pointer moved. And I'll show you the code for pointer moved in the next slide. Now, pointer cancel is highlighted here because it's a brand new event. You haven't seen this anywhere else, and you're probably not used to thinking about losing a pointer. Like, why would you think about that? Well, we urge you to think about it because it can really affect the user's experience. You can do 3 things. You can do nothing, which we don't advise, unless you've thought about it and you choose to do nothing, and that's fine. You can handle it like I've done here as a release. So in my application, I'm drawing lines. It's not very complicated. If I lose the pointer, I just complete the line. It's not a big deal. But what if I'm doing a high-fidelity scenario? Maybe it's a Photoshop app, something that really, you have to have pixel perfection. Well, in that case, maybe you want to undo the action. Maybe you can't trust that pointer input anymore, so you're rolling back. And so another slide here is the code for the pointer moved. Now, I've kind of taken away all the extra stuff that was kind of just drawing the line. But I want to dive into the pointer moved event args and how you can get to the properties and what you can do with it. So I've hooked the pointer moved here. You've got something called the pointer event args. And you can see the first thing I'm doing is getting the pointer point, which I mentioned. So that's pointer generate pointer points. So every time I get a pointer moved, I'm getting a new pointer point, similar, again, to the mouse move. So I'm getting the current point relative to a UI element, in this case, the layout root. And then I'm creating a new line. And I've skipped some code here. But the important part is that I'm getting the position off that pointer point. We have a position structure. I'm diving into it, getting the x and the y. And then I'm setting the stroke thickness. And I'm basing that off the pressure. So the properties has a pressure object there, or pressure value. And again, this is where we're talking about, we've kind of tried to make it easy in your life to code for touch, get mouse and pen for free. What if your device doesn't support pressure? What's going to happen here? Well, we won't throw an error. In fact, we provide you a smart default. So you'll get a smart default to avoid any sort of bad user experience. So whether you're using touch, mouse, or pen, it still works. OK, so we're coming to the end of the talk. And I've covered gestures, I've covered manipulations, and I've covered pointers. So again, gestures and manipulations are raised from the Windows gesture recognizer in response to user data. Pointers are that low-level input that we actually feed to the gesture recognizer. So the timeline looks something like this. When I press my finger down, I get a pointer pressed event. When I release it, I get a pointer released event. At the same time I've pressed and released, that data is being fed to the gesture recognizer behind the scenes. If this action, press and release, is actually a tap. So I press, I get the event for it. I release, I get the released event. And I'll also get a tap event following that. If I've opted in for manipulations, I'll start to get the manipulation event cycle as well. So some tips and tricks. There's some things that aren't entirely evident about the API that you need to know before you get started. So I've mentioned panning and zooming, and that's in the scroll viewer. But there's also translation and scaling using the manipulation API. So what's the difference here? Well, if you remember, I mentioned that we've made significant investments to make sure that panning and zooming is buttery smooth. This is all happening on an independent thread. So we've got a pipe from the input stack to the output stack. So even if your UI thread is busy, you can still get that buttery smooth panning and zooming experience in your app. And that's why I encourage you to use the scroll viewer. That's what you want to use in your apps. Now, translation and scaling, that's the manipulation events. That's happening on the UI thread. And so if your UI thread is busy for whatever reason, doing some other processing, you may notice a little bit of lag or a downgrade in performance. But for smooth panning and zooming, I can't stress it enough. Use the scroll viewer. It's built in. And you saw how easy it is to configure some of those great experiences. Snap points, rails, it's all there. So the scroll viewer and the manipulation API. So this is an interesting one. So I'm talking about how you can pan and zoom off thread using the scroll viewer. But how do you know that's happening in your app? Well, we still raise manipulation events to the scroll viewer. The difference is that when it's happening off thread, when you're doing panning and zooming on an independent thread, those events are reactive. We're telling you what's happened. So if you pan, you'll get the manipulation delta events, but we're telling you what's happened. You've panned 10 pixels. Or the users panned 10 pixels. They panned 20 pixels. They panned 30 pixels. You don't have a chance to stop that action because it's all happening on an independent thread. But we're telling you at least, hey, this is what is happening. As opposed to the manipulation events, using the manipulation API that happens on the UI thread, those are proactive events. We're telling you this is what the user is doing. You need to react, and you need to actually apply that transform like you saw in the code snippet. So you need to actually do something to manipulate the element. And finally, click versus tap. You've probably heard people use this synonymously. They say click, they say tap. Is there a difference? What's the difference? Well, there is a difference. It's fine to use it synonymously. I mean, it's OK. But a tap, you want to use tap when you think you'll also have a manipulation. So I'm going to switch back to memories real quick. And let me go. So you notice here that I'm touching the screen. Actually, this is a good location. So I'm touching the screen, and I'm able to pan. But if I release my finger, if I tap, you can see it's being selected. So I'm using tap because I know the user may also want to pan. So see how I'm not deselecting it right now? But if I release my finger, it's still selected. That's the advantage of tap. Tap should be used in conjunction with manipulations. Now, if this was a click instead, when I move my finger like this, and I came back to the element, this would unselect. So click should be only used for button scenarios. And you'll see in our code that we have an interface iButton base. And we use click on iButton base. So all our button controls behave like buttons, but everything else should be using tap if you're going to use it with manipulations. Oops. OK, so let's recap what we learned here. So in the first demo, you saw that you can easily build great touch apps supporting the common touch scenarios out of the box using our controls. I showed you scroll viewer, grid view. You saw flip view, a quick image of flip view, and list view as well. So these are and the app bar and our text controls. They all support touch interactions in a great way. And it's out of the box. It's free. It's easy to use. I showed you gestures, manipulations, and pointers. These are powerful. You can use our powerful touch API to create advanced scenarios. So gestures were tap, right tap, and holding. Manipulations were scaling, translating, and zooming. And the pointers, of course, were the press, the release, and the moves, and that whole family. The key takeaway here is please code for touch first. Think about touch first. Windows 8 is touch first. So code for touch and get mouse and pen in a unified way. And in many cases, you'll get it for free. So you saw that our gesture recognizer detects gestures for touch, mouse, and pen. Our pointer umbrella, actually, the events work for arrays for touch, mouse, and pen. And the properties on pointer point provide you smart defaults if they're not supported by that device. And finally, XAML is XAML. You know this stuff. I mean, we haven't got a mouse API. We've replaced it with a pointer API. But it should be intuitive and innate. You should innately know how to use that API. So you have gestures and manipulations, these new concepts. But I think that when you start actually building apps, you'll see that it's familiar. Even though it looks a little bit different than new concepts, it's still familiar. XAML is still XAML. And again, so please go ahead and create these great touch apps, and please provide feedback. If there are any scenarios that you think we've missed, any of your scenarios that you don't think we've covered or you think we're not thinking about, please, please, please provide feedback. I mean, I'll be available after the session. There'll be forums. I think there's a link at the end of the slide deck. And also, you can find me on Twitter, somewhere or the other. Oh, so before I get to that, related sessions, I talked about controls, list view, grid view. Hamid went into detail on the list view and the grid view yesterday. You can probably find that on demand. And I mentioned text controls. Chapalo has a talk coming up, I think, today at 5 o'clock in this room, where he'll go over the tech stack and also talk about printing as well. So I didn't show too much code. I kind of walked through manipulation samples and whatnot. But if you want to figure out how to do that drawing with the finger, that's in the SDK samples. A lot of the gesture stuff is in the SDK samples. So that's online as well, and I think you'll find links on the forums. And if you have any questions, find me right after. Find me in the boots. Twitter, it's @AllNerdSmile. And thank you for your help. I'm sorry, thank you for coming.